Lesson 4 practice. Number 1. Describe the graphical transformations on f of x equals 9 to the x to produce g of x. So on part A, the 1/2 in the front is the a value. So if the a value is in between 0 and 1, that means you have a vertical compression. If that 1/2 had been anything larger than 1, that would be a vertical stretch. So this is just a vertical compression. As far as the original parent function goes, think of the 9 as 9 to the x, and the x would be in parentheses. So when we look back at our function in part A, the fact that there's this negative sign right in front of the x, that would be kind of inside the parentheses. So that would be your reflection over the y-axis. And then the plus 3 in the back would not be inside the parentheses, so that would be a vertical translation up 3. For part B, its function notation is a little bit different. So instead of seeing the 9 to the x, you just see the f of x. So f is the original parent function, and then the 5 and the -2 and the -8 are all different types of transformations that have happened to the original parent function. So the 5 in the front, since it's bigger than 1, that's a vertical stretch. The -2 is inside the parentheses, so that's a horizontal translation. Those are always the opposite of what we think they should be. So horizontal translation right 2. And then that last one, the -8, is outside the parentheses, so that's a vertical translation down 8. On part C, the negative sign in front would be a reflection over the x-axis. And then the +1 would be kind of inside the parentheses since it's inside the exponent. So that would be a horizontal translation, left 1. Because those horizontal translations are always the opposite of what we think they should be. On number 2, they already graphed log of x for us, and then we want to transform this new function m of x, so that +4 makes us go left 4 because it's inside the parentheses. The -2 makes us go down 2. So the original function has a vertical asymptote right here at x equals 0. So if I'm going to move left 4, I want to make sure that my new vertical asymptote is at x equals -4. And I'll go ahead and write that down off to the right, x equals -4, because I had to move the whole graph to the left. As far as actually plotting the points on the new graph, the one point that it's easy to tell where it hits on the original function was 1, 0. So right here where I'm putting that red dot, that's 1, 0. So I'm going to take that point and I'm going to move it left 4 and down 2. So 1, 2, 3, 4 to the left, down 2 would get me right here. It kind of moved a little bit. Let me see if I can move it back over a little bit. Yeah, right there. So that's left 4, down 2. And then I would want to just draw my graph in. So about like this. And I'd want to label it m of x. So for my domain, I don't have any x values less than -4, so I'd want to say -4 to infinity. Those are all my x values that that blue graph covers. My range would be -infinity to positive infinity, because that blue graph goes down forever and it goes up forever. On 3, we have a logarithmic function already graphed, and then let's move the 3 points like they ask us to, and then we're going to say the new asymptotes. So that negative sign in the front is the reflection over the x-axis, or basically flipping the graph upside down. The -3 is inside the parentheses, so that's a horizontal translation, right 3. And then that +6 would be our vertical translation, up 6. So when I look at my original graph, I have a vertical asymptote right here at x equals 0. So the asymptote for f of x is x equals 0. And then now, with my new graph, I want to move right 3 and up 6. So I'm going to start with this point right here, 3, 1. I want to go right 3 up 6. So right there, and I probably should use a different color. So right there. And then I also need to move this point that was originally at 1, 0. I need to move that point right 3 and up 6. So right there. And then that last point's a little hard to do super accurately because the x value is a decimal, but at least the y value is -1. So I'm talking about this little point right here. The y value is -1, so at least we can make that one accurate. So we want to take that point and go right 3 up 6. So the right 3 is where it's a little tricky. And then the up 6 should get us right about here. And then I should put in my vertical asymptote for sure. So my vertical asymptote was normally at x equals 0, but now I'm moving to the right 3, so it should be at x equals 3. So I'll put that into my picture. There's my vertical asymptote. And then I should draw in, oh, do we have a reflection? We did. So I was about to draw the curve the same orientation as the original graph, but then I looked back and remembered we had a reflection over the x-axis. So I need to fix this a lot. Let's see what we can do here. Let me erase this. Sorry, guys. All right, let's try this again. So if we were going to do a reflection over the x-axis, then this point that I'm doing in blue, that would stay the same. But then this point would flip up here, and this point would flip down here. So then the graph would open the other direction, like it would turn upside down. It would reflect over the x-axis. So then we want to move those points right 3 and up 6. Okay, so those blue dots should go right 3 and up 6. Let's do... So right 3, 1, 2, 3, and then up 6. 1, 2, 3, 4, 5, 6. So that was this point that I just moved. Now I'm going to do this one. So right 3, 1, 2, 3, and then up 6. And then this last one here, we're going to go right 3 and then up 6. Okay, that's a little bit better. And then, again, the vertical asymptote is still supposed to be at x equals 3. So this graph is the other direction compared to the original graph because of the reflection, and then everything still moved right 3 and up 6 from those blue points that I got after I flipped everything over the x-axis. So our new vertical asymptote for k of x, which by the way I should label that on my graph, k of x, is x equals 3. So the rest of the worksheet is mixed review. All of these questions, or problems similar to all of these questions, are on the summative. So with number 4, I highly recommend we make a table of values to help us make this sketch fairly accurate. So off to the right here, I'm just going to do a little table of values. And actually, let's put it off to the left. That way we don't run out of space when we're writing our domain and range and all those key features. So I'm going to just do a -1, a 0, and a 1 to keep it nice and simple, just to get the general shape of the graph to make sure we have it going the right direction. So when x is -1, you would have to basically take 1/5, like this, 1/5, raised up to the -1. Since it's a negative exponent, that actually flips the fraction upside down. So it just becomes regular 5. For 0, anything raised to the 0 power is 1. And then 1/5 raised to the first power is just 1/5. So basically at -1, 5, we're about here-ish. 0, 1, we're about here-ish. And then 1, 1/5, we're about here-ish. That way you're just getting the general shape of your curve and you're making sure it's going the right way. So that would be g of x. So my domain would be all real numbers. I could have all positives and negative x values. My range, I'm never going to have any negative y values. So we'll do 0 to infinity because I'm never going to go below the x-axis. For the asymptotes, I'm going to say y equals 0 because I'm never going to cross this horizontal line that I'm drawing in right there. That's y equals 0. I'm never going to cross that. For the intercept, 0, 1. So I cross the y-axis at 1. And for end behavior, as x approaches infinity, your g of x, your output values, get closer and closer and closer to 0. As x approaches negative infinity, your output values, your g of x values, get closer and closer and closer to infinity. And then for interval of increase or decrease, I'm going to highlight the word decrease because when we look at the function from left to right, it's going down the whole time. So it's decreasing over its entire domain, which is negative infinity to infinity. On 5, if we want to solve this inequality, we need everything on one side and then 0 on the other side. So I'm going to subtract 18x from both sides to start. Now that everything's on one side, we can factor, set each factor equal to 0, and then solve for x. So it looks like I have a greatest common factor of 3x. So I need to divide all the terms by the GCF of 3x, like so. Then, when you look at your leftovers in the parentheses, it's a basic trinomial. So we're looking for two numbers that multiply to -6. And then those same two numbers have to add to 5. So let's see here. Multiply to 6 and add to 5. Or sorry, multiply to -6 and add to 5. So does 6 and -1 work? 6 times -1 is -6. 6 plus -1 is +5. So yes, that works. So at this point, we want to set each factor equal to 0 and solve for x. So x equals 0, x equals -6, x equals 1. So at this point, probably the easiest thing to do is do a little sketch over here. So we know we have x-intercepts at -6, 0, and 1. Okay, so -6, 0, and 1. When I look back at this step right here, I'm using my prior knowledge from first semester about end behavior. So this is a cubic function with a positive a value. So I know it has to have opposite end behavior because of the odd degree. It's a third degree function. And I know the end behavior needs to look something like this. And again, that's because of the positive a value. It would go the exact opposite way if it was a negative a value. At the very end here, we want to know where that function is greater than or equal to 0. So that would happen here and here. And we're supposed to write our answer in interval notation. So I'm going to use a square bracket because of the half little equal sign. I would use a curved parentheses if it didn't have the little half equal sign. So from -6 to 0, that's when the graph is above the x-axis, so that's when it's greater than or equal to 0, union 1 to infinity. And then that would be it. Let me make that 1 to infinity a little bit more legible. So that would be your answer. On 6, very similar to 5, so we need to get everything on one side equals 0 to start. So let me do minus 28x minus 28x. So negative 4x squared minus 28x minus 40 is less than 0. Then it looks like I have a greatest common factor of -4. So I'm going to divide everything by my GCF of -4. So GCF is out in front, leftovers in the parentheses in the back. And then looking at my leftover trinomial in the parentheses, that's a basic trinomial. So I'm looking for two numbers that multiply to 10 and add to 7. So 2 and 5. Set each factor equal to 0, solve for x. So that first equation, that doesn't make any sense. -4 does not equal 0, so you just cross that off, you don't even worry about it. On the next equation, just subtract 2 from both sides. On the next equation, subtract 5 from both sides. And then as far as actually getting our answer, again, I like to do the little sketch of the graph. You could technically use -2 and -5 as your critical values and do a bunch of test points. So if your teacher taught you that way last semester and you're comfortable with that, feel free to keep doing that. So -5 and -2. And then, again, look back at this step right here. So the polynomial before we divided out anything, before we factored it. It's a negative a value, and it's an even degree, right? The 2, it's a second degree polynomial, so it's going to be a parabola. So since the a value is negative, I know my graph is going to have to look like this. It's going to have to be concave down. So we're trying to figure out when this function is less than 0. So picture-wise on the graph, that happens here and here. That's when it's less than 0. So as I look at that picture from left to right, from -infinity all the way up to -5, that graph is under the x-axis. It's less than 0. I'm going to use curved parentheses because I don't have the little half equal sign. And then union -2 to positive infinity. So that's it. Those are all the x values where that graph is less than 0. So it's where it's under the x-axis. On 7, we're just solving an equation. It was partially factored for us, but when we look at that second set of parentheses, it's a basic trinomial that we need to try to factor. So 2x minus 3 just stays the same. And then that basic trinomial in the back set of parentheses, I need to factor that. So what two numbers multiply to -8 and add to -2? -4 and 2. Now that we've factored everything completely, we just set each factor equal to 0, solve for x, and we're done. So this is actually a pretty short question. It's a fairly easy question on the summative. So we've got 2x equals 3, x equals 3 halves. So there's one answer. Add 4 to both sides to get your second answer. Subtract 2 from both sides to get your third answer. Done. On 8, you have a radical. So you have a square root. You have to isolate the part I just highlighted in green first before you try to undo the radical. Meaning I have to add x to both sides of this equation so that I can isolate the square root, the 2x plus 2. From here, since the square root is now isolated, the only way to undo a square root is to square it. Raise it up to the second power. Whatever you do to one side of the equation, you want to do it to the other side to keep it balanced. So 2x plus 2 equals, and then x minus 3 squared, I'm going to need to write out like this, x minus 3 times itself. On the right side of the equation, we're going to need to FOIL that out. So first times first, x times x is x squared. Outside times outside is x times negative 3, which is negative 3x. Inside times inside is negative 3 times x, so another negative 3x. And then last times last, negative 3 times negative 3, positive 9. Let's go ahead and combine our like terms on the right side. So negative 3x minus 3x is negative 6x. Drag down the plus 9. And then since we have x terms and x squared terms, we want to get everything on one side equals 0. So we want to subtract 2x and subtract 2 from both sides of the equation. And then we have our basic trinomial. So I want two numbers that multiply to 7 and add to negative 8. So negative 7 and negative 1. Set each factor to equal to 0, solve for x. So x equals 7 and x equals 1. Now, I know you're really tempted to stop here, but we do need to check those answers because we might have an extraneous solution that we're going to have to throw out. So I'm going back up to my original equation. I'm going to put 7 in wherever I see an x. So I'm putting a 7 in wherever I see an x. And then I'm not going to solve anything. I'm just going to keep simplifying the left side of the equation and see if it ends up equaling negative 3 or not. So just keep simplifying. So under the square root, 2 times 7 is 14. And then under the square root, 14 plus 2 is 16. Square root of 16 is 4. Negative 7 plus 4 is negative 3. So yes, that works. So 7 is an answer. Now, I have to check the other answer, x equals 1. So back to my original function, I'm putting a 1 in wherever I see an x. And then again, I'm not solving the equation, I'm just following order of operations to simplify the left side. So under the square root, 2 plus 2 is 4. Square root of 4 is 2. Negative 1 plus 2 is 1. 1 does not equal negative 3. So x equals 1 is not a solution to this equation. It's an extraneous root, so we have to throw it out. And that is all.